Hello, in this video we'll talk about regression. Regression is a simple statistical technique used to model dependence of one variable on another or a set of another input variables. It is a part of inferential statistics, so not descriptive statistics. It is one of the most widely known and used analytic techniques in the statistics. It can be used for hypothesis testing. It means if we make a hypothesis, we can test it using regression, or we can use it for forecasting or prediction of the future. So let's look at the difference between correlation versus regression. Correlation makes no a priori assumption of whether one variable is dependent on the other. It also does not concern about what is the relationship between these variables. It just gives an estimate of the degree of association between two variables. On the other hand, regression attempts to describe dependence of the response variable or the y variable on explanatory or the x variable. It implicitly assumes that there is a one-way causal effect between these two. So x causes y. That's what we do when we are dealing with regression. If regression equation is built between one response variable and one explanatory variable, we call it the simple regression. Let's say I want to determine how the salary of a person varies with their education level. So education level is my explanatory variable, salary is my response variable, and we have a simple regression. Multiple regression, on the other hand, is the extension of simple regression where explanatory variables are more than one. So response variable is just going to be one, but we may have multiple explanatory or x variables. Let's say we want to determine again the salary of a person, but this time for explanatory variables we take more than one. Let's say in addition to education level, we also want to consider the age of a person, what was their graduation major, how many years have passed since graduation, do they have certifications, etc. So multiple variables can explain one response variable. This is multiple regression. Now, how do we develop a regression model? The simplest thing that one can do is to draw a scatter plot like this, where the y-axis represents response variable and the x-axis represents the explanatory variable. A scatter plot would then show the changes in the response variable or y variable as a function of changes in the x variable. In this case, if you see, it seems like there is a positive relationship between these two variables. As x increases, the value of y also increases. So in reality, if you are trying to build a regression equation, you are trying to find the signature of a straight line passing through right between the plotted dots. And remember, there can be multiple straight lines that can be passing through these dots. So to build a regression, we want to minimize the distance between the dots and the line. To do that, we can use several algorithms. The most popular one is OLS, or ordinary least squares method, which finds a line that minimizes the squared of errors. Let's have a look at the regression equation. So here is the simple linear equation, y equals beta 0 plus beta 1 times x. Here beta 0 is called the intercept and beta 1 is called the slope. Once OLS determines the value of these two coefficients, beta 0 and beta 1, the simple equation can be used to forecast the values of y for given values of x. So we can do that. In case of multiple linear regression, OLS can find out multiple coefficients like beta 0, beta 1, beta 2, because we have multiple x or multiple variables here. So x1, x2, x3, xn, we can go as many as we want. You can also look at the sign of these betas, these coefficients. What that means is for some of them it will be positive, sometimes it will be negative, indicating what's the relationship between these variables. Now let's look at the process of developing a regression model. So like we discussed, we start with the tabulated data and then we do data assessment either based on scatter plot and correlation. And then model fit is calculated by transforming the data and parameters like beta 0, beta 1, etc. are estimated. Now we do a model assessment. So we try to determine if this model good enough. So there are several tests in there for testing the assumptions of the regression model, and the model fit is being assessed. To know if the model is good enough, we can look at several criteria such as R-squared values. A good R-squared value is usually closer to 1. So if the R-squared value is towards 0, it's not a good model. As the R-squared value increase and go closer to 1, they are better. So if the R-squared value is, let's say, 0.5, that's in between. 0.8 is much better. Now p-values are better if they are closer to 0, and we also have different error measures for different algorithms. So we want our errors to be minimum. We want the p-values to be going towards significance, indicating lower values. R-squared, we want that to be higher value. Now, there are several assumptions in a regression model. For example, linearity. It means that the relationship between the response variable and the explanatory variables are linear. Then we have independence assumption, which means the errors of the response variables are uncorrelated with each other. Then we have normality assumption, which means that the errors of the response variable are normally distributed. The next assumption is about constant variance. It states that the response variable have the same variance in their error regardless of the values of the explanatory variables. Again, we have the multicollinearity assumption, which is very important. It means that the explanatory variables are not correlated among themselves. So if you have two variables, x1 and x2, they should not be correlated with each other. So there are several techniques developed already to identify, make sure that these assumptions are met. If they are not met, if there are certain violations, there are techniques available to mitigate those. Logistic regression modeling is similar to linear regression in that it also aims to regress a mathematical function that explains the relationship between the response variable and the explanatory variable using a sample of observations. It is a popular statistics-based classification algorithm. Now, again, there is a difference between linear regression and logistic regression. The difference is that in logistic regression, the output or the target variable or the response variable, y, is a binomial or binary variable. So it's categorical variable. In linear regression, our output variable or response variable y is a numeric variable. So that's the biggest difference between linear regression and logistic regression. This is the function representing logical regression, where the odds are represented on the x-axis. So we have x-axis or independent variables, and on the y-axis the response variable is going to be 0 to 1. Let's talk about time series forecasting. Time series forecasting is the use of mathematical modeling to predict future values of the variable based on previously observed values. In time series plot, there are two variables, the response variable and the time variable. So the response variable is on the y-axis, and on the x-axis we have the time variable.